The broadcast is now starting. All attendees are in listen-only mode.
Okay, good morning, everybody. And today is Sunday, April 12, and this is a transportation workshop. Thank you very much for coming this morning. You woke up early. That's a good sign that we are ready. And I hope that everybody is healthy and keep doing our best. I did my best. I collect some problems from different sources, from my books and from my previous notes and so on. And I send it to you this morning, 25 problems. I did not forget, by the way, for the mini exam number 1 and mini exam number 2. I know we don't solve every single problem here, and and uh, and some of you indicated that we did not get the solution. Yes, I am aware of that, and I'm really busy. I try to do my best, but keep working on the material that we covered. Any mini exam I send to you, or any additional material I send you, try to do your best to get the maximum benefit of this period. So let us do our best. In fact, because last night I didn't sleep at all, so I phone calls, a lot of issues here and there, especially overseas, family and all these things. So I have to. Anyhow, let me do our best. And also I sent to you also, just in case if you are interested, I do have a class for the seismic from 1 to 4. So from 1 to 4, 1 to 5, I believe, 1 to 5 p.m. today. Seismic, if you are interested in attending seismic, seismic workshop based on the new code or codes. So the same ID as I mentioned before. So I did my best here, getting some problems, and take it seriously, as always say, and try to do your best to understand the concept as much as you can. So if you look to the first problem, this is a signal warrant based on the MUTCD 2009. 2009, let me write the entire, and I explain the warrant, and I send you a flow chart for the warrant number 1, which is the 8-hour, which is the most confusing one. And I said that I hope that I will have time to finish all the warrants from 2 all the way to 9, some kind of a flow chart, the one like the one I send it to you. So a flow chart, I found it may be useful. Flow chart, and I hope that I can complete this one day. So here, for example, he is asking, the city of Fresno is investigating. I hope that you get a chance to print it. Sorry, again, I should do all my best to email it to you as early as I can, but always the things are getting in the way, and so I hope that you get a chance to print it out. If not, follow me, or just, and when you print it, you will hopefully be able to retract all the information that we talked about. So here he is talking about the 85th percentile mile per hour. This is V. This is the speed. So when we see the V, especially the V major, we have to pay attention. He gave it you 40 mile per hour mph, because if the speed goes beyond certain limit, as all of you know, which is a 45 mile per hour along the major street, and when the population hit a certain number, which is the 10,000, so we can use different criteria for so the intersection has two lanes in the major direction. So basically we have a major and minor. You don't have to draw a picture, but it will be a good idea if you can draw a very quick schematic for the intersection. Let me see if anybody has a problem with the audio. Post the handout here. Good. I don't know what they mean by post the handout here. If you enroll in the class, I sent it to you this morning. Hemin, I don't know Hemin Muhammad. I need to understand what. Would you please post the handout here? Oh, yeah, probably if you didn't get it, that's fine. You will get it. I will send it again, Hemin, okay? Hemin Muhammad, you asked me to post the handout. Okay, if you are referring to the handout of the MU to CD, the flow chart, I have no problem with that. I can locate it very quick, and let's see if I. If you are referring to this, Muhammad, this is the handout I'm referring to. If you didn't receive it because probably you didn't attend before, or for some reason, if you didn't, but I send it out as far as I know, and I will be glad to go over it one more time very quick. So warrant number one, which is the 8-hour vehicular volume, they provided us with the big table in the MUTCD 2009, which is the current, excuse me, the current code. So the 8-hour volume, vehicular volume criteria is based on the number of lanes and the volume. So if we consider this illustration, which is we have a major street, and here I assume that we have two lanes in each direction. The MUTCD, they call this is an approach. So approach is a direction. So this is an approach and this is an approach. This is the definition of approach per MUTCD. So if this is a major street, the MUTCD is looking to the major street volume, and they consider both volumes. Here it is. This is why I put it that this way. volume of both approaches. So when we do the calculations, if the volume per approach is given separately, and sometimes they do that, by the way, you're supposed to add this to this. So they will tell you, for example, the westbound, eastbound, northbound, southbound, you have to know exactly. Here, for example, this problem here, that for major approach, or the major street, sorry, he gave you the combined approaches. So here, he already add them up. But another problem, you will find that this table is divided into two, okay? And they will tell you, okay, the eastbound and the westbound, northbound, southbound, it depends on the direction. And in this case, you have to add the total. So in this case, along the major street, and this is again, so this is, for example, this is a northbound, and this is a southbound, for example. Okay, assuming another orientation, and he gave you a volume here and a volume here. So in this case, you have to say total. So you add the numbers here and the numbers here to put them here. And these are the numbers that we are going to use to enter the table and decide if the warrant has been met or not. So I need you to be aware of that. So here it is already combined. So this is make our life a little bit easier. So, but for the minor street, the current code is, or the current is, okay, minor street, and you have to define what is a minor and major. Okay, so this is also is called approach, and this is called approach. So approach, it is one approach volume and one approach. Okay, in this case, since we are not adding the volumes on both approaches of the minor street, the code is saying the larger volume. So in this case, we are looking for the larger. And this is why you will find that the table that's given, vehicles on the highest volume minor street approaches, okay? So in this case, the highest volume, whatever approach has the largest volume is going to be considered. So far, so good. So this is the thing that I was referring to, or the flow chart. I call it a flow chart. I did this in order to help, and I hope that, as I told you, that flow chart, and maybe there is something similar. I didn't search it really if there is something similar on the net or not, and you can search it if you have any flow chart that will help you to understand the warrants. It will be a very good idea. So anyhow, so this is called condition A, which is the minimum vehicular volume. They came up with another situation, they call it condition B. And we'll see when we should apply the condition A, when we should apply the condition B. So this is the interruption of the continuous traffic. Again, the same approach, or the same concept, sorry, let me much better. This is the major, and this is a minor. These are the major. So in this case, we are taking the two approaches together, the volume, and the same thing for the minor street, which is this one here, and the highest volume. This condition B, as in boy, intent for what? That the minor intersection traffic suffers excessive delay or conflict in entering or crossing the major street. So they came up with the condition A in order to take care of the traffic along the minor street where excessive delay or conflict with the traffic on the major street. So every criteria they put, they have a justification, as I went over all of them when we covered signal warrants. So we have something that's called condition A in the table, and the condition B And this table is given in the MUTCD and is given in every all books available in the market, including mine, my transportation reference module manual. And if we go to chapter 6 for the signal, okay, I arrange it as I told you before to the best of my knowledge based on the NCEES, not NCEES, yeah, NCEES. Okay, so this is the table that it was extracted from the, and this is a condition A, and this is a condition B. And after that, they give the number of lanes and the volumes, and we have what is known as 100%, 80%, 70%, and 56. Already we covered this before many times, in fact, at least two times. And the footnotes are extremely important, these footnotes here. So what I did, I took this, okay, and put it in the flow chart, these fine print below the table. I put it in the flow chart to illustrate to you or to explain to you. So warrant number 1 is considered, which is the 8-hour warrant. 8-hour warrant is considered that to be met if, and this is, I call it step number 1, basic minimum hourly volume. If we have to pay attention to word or and. So if 100% columns major and minor of condition A, or 100% columns major and minor condition B. So either condition A or condition B for the 100% column, because we have a column here, it's called 100%. Here it is, 100% for condition A and 100% for condition B. So if you have met the requirements or the volume, here in this case, you are, or we are, they came up with something is called 70%. 70% can be used instead of the 100%. But when we use the 70%. So, and this is step number 2 of my flow chart. This is step number 1 and step number 2. Step number 2, if the V major exceeding 40 miles per hour or the population less than 10,000, and this is a key, by the way, I consider this is a key in the calculations. The moment you see in the problem statement that the major or the speed along the major, V major, exceeding 40 miles per hour, or he is hinting or telling you the population is less than 10,000, I will jump immediately here. Okay? So warrant number 1 is satisfied if 1, and again, I put it boldface as you can see, if one of the following exists. Probably, I think it is better to add S, if the one of the following exists. Maybe I will. Okay. The 70% columns for the major and the minor for condition A, again the word or, the 70% major and minor for condition B. Because we do have, in fact, we have the 70%. Here are the 70% columns. Here it is. 70% and 70%. This is step number 2. Step number 3, we will go to 80% and 56%. 80%, which is, I call it step number 3. Warrant number 1 is considered to be satisfied if the following exists and both. You see the word both, I put it. So you have to say and here. Okay, since both conditions must be met. So the 80% columns along the major and the minor for condition A and the 80% columns major and minor for condition B. And this is step number 3. Step number 4, which is related to the 56%. And the 56% similar to the 70% in the sense that if the V major is given to be exceeding 40 miles per hour, or remember the word or population is less than 10,000. So in this case, again, the word both here and here. And finally, I translate all this into a very simple diagram, because engineers always like diagrams and tables and the charts, make it easy for them to follow. So the warrant number 1, I put it here, the 100%, the 70%, 80%, 56%. Those are the 4 columns given in the table. And or the 70% and the 56% will be used only if the speed or V major exceeding the 40 mile per hour, exceeding, not equal. For example, in our problem here, he told you that it is speed 40 mile per hour. So this is not qualified, okay, because exactly 40, the speed must be greater than. He did not mention anything about the population, but if you remember the problem that we solved it together in the NCEES, and it does have the population, and we solve this problem together to the best of my knowledge. The problem, this one here, problem number 530, it does have the population 12,000. So he gave you the V major, it is 45 mile per hour, and he gave you population also 12,000. But not necessarily to be both in order to. So this is a summary of the and if you remember the 80% and 56%, they are saying that both, that mean this and this, and this and this. You have to be careful about that, okay? So in this case, and you can see here, what I meant by they go together, these two here, okay, because the word and, okay, and this, the or, so they go together. This is what I meant by go together, but it's not required to achieve this and achieve this, no. Any, okay, as indicated here, 100% of condition A or condition B, if satisfy only one, that's it. That means that the warrant has been met. Okay, so this has been discussed before, but I will be glad to discuss it again because I know this topic is a little bit, and always I will include some problems. I don't know how many problems did I include this. I include one problem number 18 related to warrant number 9. This is a warrant number 9, as all of you know, warrant number 9 which is related to the railroad, and we can go over this. And as I told you, here it is problem here, problem number 17. Okay. Also related to traffic signals, and I don't remember if I include more. So anyhow, so I will be glad to scan this again and send it with my notes. And I didn't get a chance for those who attended the class yesterday, the civil bridge AM and the construction BM. I said that I will do it after I finish, but believe me, after I finish, I was almost a case. So, because also the night before I didn't sleep well, but I'm trying to push myself as hard as I can to help you guys, to keep you busy because you are sitting home, and I know this crisis. So let's do our best, okay? So if you have any question, you are very welcome to ask, and I will do my best to help as much as I can. Okay. So let us look to this problem here, and I will get close as much as I can. If you have my book or any other book, or if you have the MUTCD, here he's referring to warrant number 1, 2 only, and 3. So warrant number 1, as all of you know, this is the 8-hour warrant. 8 hour. And the warrant number 2, they reduce the 8 hours, they make it 4 hours. 50% reduction. Okay, the 4 hours. And after the 4 hours, warrant number 3, the peak hour. So I needed to remember them in order like that. Peak hour. One specific hour of the day, we have a peak because of school or business or shopping centers and so on. So they go from the 8 hours to 4 hours to the peak hour, one specific hour. And if you look to this, you will find that it's saying that and they have 2 lanes in the major direction and 1 lane. So we have the major, we have 2 lanes in each direction. Assuming this is a major road and this is a minor. And the minor, it does have 1 lane in each direction, because the table for warrant number 1, it does have the number of lanes. So I have here 2 and I have here 1. So when I go to the table, I need to select 2, 1. Okay, so the table, it does have the either for condition A or condition B, the number of lanes here. Okay, so the major street is given in 1 column here, and the minor street, and you need to select the 1, 1, 2, 1, and so on. And the same story for the condition B. And as I told you, the best way to master this subject is to practice and practice and practice. And if we did a mistake, no problem. This is the right time of doing mistakes. So the warrant number 1, they say that average 8 hours, 8 hours on an average day. So we have 2, 1, and we have 40 miles per hour. So in this case, we are not having anything about the look into this chart here. So this and this are not applicable in my case, the 70% or 50%, 56%. So I have either 100% or 80%. And by the way, just for the sake of discussion, if you look to the volumes in the condition A, the volumes here, 500, we have 750 here. 600, 900 here. Okay, I needed to be aware of that. The volumes here, the volumes, okay? So for the major street, 5, 7, 4, 6, 350, 525, 280, 420. But if you look to the volume, this is a major. If you look to the minor, the picture is reversed. Here is 150, here is 75. 120 and so on. So the volumes here more than here. I needed to pay attention to that, okay? So based on that, even if you don't have the book with you right now, or the table, this table from whatever book you have right now, do you think warrant number 1 has been met? Warrant number 1. I look to these are 8 hours. 1, 2, 3, 4, 5, 6, 7, 8. And here are the volumes for the major, and here the volumes for the minor, the highest volume. So in this case, if you look to warrant number 1, we need, okay, if you go with 100%, okay, for 2 and 1, because we have 2 and 1. So I will go with 2 and 1, 2 major, 1 for 100%. I need 600 along the major and along the minor 150. Okay, the 8 hours must have these numbers 600 and 150. Okay, so 600, I have 600, I have 550 here. That's it. If you would like to say, oh, wait a second, you tried 100% under condition A, but it says that I can go to condition A and B under 80%. Let me just do it, and I will tell you why I'm doing this. If you go under 80%, okay, for condition A and B, you must meet condition A and B. So this here, 480 and 120. For here, I have 720, and here I have 60. We just failed the 550. So in this case, the 720, obviously it will make this failed. So warrant number 1 has not been met. So warrant number 1, the answer is no. If this is 100% sure, I can eliminate this answer, and I can eliminate this answer. Agree or disagree? We need to make sure that all of us are on the same page, because I need to make sure that you really understand all these things. Okay, so the answer is no, as I heard it from one of you. If you disagree with our friend or yes, agree with me, let me know. So far so good. Warrant number 2, 4 hours. The 4 hours, they are saying that, which I will take you, the 4 hours, which is also MUTCD, the 4 hours. The 4 hours, they give us 2 charts. This a chart here, which is I call it the base. And this is the figure 4C-1 on page 440 if you have the original document with you. So this is the base or the basic condition, if you'd like to say the basic or the base. And you will find that along the x-axis we have the major street total volume, both approaches. So this is the major volume, major, and the major both approaches. And the y-axis, which is, this is vehicle per hour, by the way, VPH. VPH. This is a minor. And in your book, you try to write as much as you can. And it is one approach, or the higher volume. Higher volume. Also, it is VPH, vehicle per hour. And they came up with another chart below that, which is figure 4C-2. And this is the 70% factor. And the 70% factor will be used only if the V major exceeding the 40 mile per hour, or community less than 10,000, or population less than 10,000. This is the way I will do it. So you have to decide, are you going to use this chart or this chart, the base or the 70% factor chart, based on the given information. Obviously, I'm not entitled to use this. I will use this because I don't have the 40. I have 40 mile per hour only, so it's not exceeding. And they came up with 3 graphs as shown. We have 2 and 2, number of lanes, 2, 1, and 1, 1. The first number is referring to the major, and the second one referring to the minor. So I have 2, 2, 2, 1, 1, 1. And these are the number of lanes per direction, not the total number of lanes. And they provide us with these 3 and I know probably some of you will say, wait a second, why you jump on warrant number 2? Why you don't go to warrant number 3 directly? That's just, I put them in order. Because right now, we eliminated one answer A and answer B because warrant number 1 is out. So 2 only, which is the current one we are doing right now. And here 2 and 3. So some of you may say that you already tested 1 and we eliminated 2 answers. Okay. Why you don't go directly to 3? And I agree with you, go to 3. And if you emit number 3, that means that the answer is D, without checking number 2. Are you following me? So also the arrangement here is very, very important. And this is exactly similar to what we discussed. But I just put them in order. But just it's worth to mention this because when we solve this problem together, the one in the NCAAS, the blue book, they have also warrant number 2, 1727, and 127. and we solve it. And again, the process of elimination is very powerful. You can say that you will find 777 in the 3 answers, 2, 2, 2 in the 3 answers, and 1 in. So again, the selection is very, very important, which one you start with in order to minimize the time. Are you following me? And I'll be glad to go over this problem again in the NCEES if you did not get the whole concept in the first time that we covered. I have no problem with that. We can work it again one more time and see what will be. Okay, so but here, if I were you, probably I will jump on number 3, which is the peak hour. And after that, if the number 3 is meeting the warrant, that means that the answer is D blindly without checking number 2. But I check number 2 on the way, just okay, to explain it one more time. This is my intent. Okay, so I don't like it. Okay, so because the 1 hour is coming, it does have some graphs also. So I said I will explain the graphs here, and the graphs for warrant number 3 will be almost the same. So the criteria here, they need any 4 hours on an average day, or of an average day. Any 4 hours where the volume along the major, both approaches, and the volume along the minor, the heaviest, they should fall above. So I will select the proper curve, and after that I will select the volume. I need 4 points, okay, to be higher or above these curves. Above means here, just barely above, even by 1 is sufficient. So it must fall above. I will write it this way, at least not on the line, fall above. And I need 4 hours. I need 4 points. 4 hours mean that 4 points must fall above the proper curve based on the number of lanes. We have 2, 1, so I'm using the middle one. 2, 1 is the middle one. This my problem is here. This is the way how the warrant number 2 is working. Warrant number 3, they are saying that, as I explained in the class, they call it the peak hour. The peak hour. 2 things I needed to pay attention to, or in fact 3 things. Every time that we talk about warrants, I needed to pay attention to the language, because the language is very important. And this is why it took years from them to come up with these regulations or these codes. So generally speaking, for warrants, or let me write it on my notes, at least when you receive my notes. So it is, today is 3/12. This transportation PM. So for warrants, or traffic signal warrants, you need to pay attention to, number 1, the the name of the warrant. Because he told you warrant number 1, warrant number 7, warrant number 8. Try to remember as much as you can as far as names. So warrant number 1, warrant number 2, 3, all the way until we hit number 9, which is railroads, school, accidents, coordination, all these things. Try to remember as much as you can. This will save some time for you during the exam. So I need you to know also the concept about or behind this warrant. And after the concept, how to examine the warrant to see if you examine the warrant itself to see if you are meeting or the warrant has been met or we are meeting the requirements for the warrants or not. And finally, so this is number 1, the name. Number 2, understand the concept or the logic behind it. Concept, why they develop it. How to examine or how to apply the warrant requirements, apply the warrant requirements. And number 4, if there is any special requirements for this warrant to be installed or special hardware or special requirements or additional requirements or simply hardware to be installed. Because sometimes they can ask you about that. And I believe I have some problems in my books, the AM book, the AMBM book, and practice exam book, to the best of my knowledge. So number 3, number 4. Specifically, if you look to this, warrant number 3, there is a statement written here that if this warrant is the only warrant met and a traffic control signal is justified by an engineering study, because they always use the word engineering study, even if the warrant has been met, they are still make the responsibility on us as engineers to make a judgment. Is the warrant justifiable or not? So they are saying it. If the warrant number 3 is the only warrant and the traffic signal is justified by an engineering study, so what? The traffic control signal should be traffic actuated, and I explained this last time. And I remember this very well, and we have a lengthy discussion, and I showed you the tables about the different type of signal design and so on. So it could be something like that, the type of traffic signal controller, permitted, semi-actuated, or the fully actuated. And as I mentioned, that the intent from this warrant number 3 is that if you do have a specific location where along the minor street, this is a major, and here is a minor, and the minor, it has a stop sign, has to come to a complete stop. Minor, they found that if you do have some kind of school here along the minor street, school, all kind of business or shopping center, any kind of that at a certain hour at the end of the day, there will be a lot of traffic will be generated here. One specific hour, maybe 4 to 5 or 3 to 4 when the school, when the businesses, and so on. So they said we need to take this into consideration because I don't like to have this long line of the people are waiting here while the major traffic is enjoying. So in this case, we are going to consider installing a signal in order to accommodate the traffic along the minor street. So this is what is meant by 1 hour, because there is one specific hour. And they came up with identical or similar, sorry, not similar. Again, the major one and the minor, all these things already I talked about it more than once. So I need for those who attended the first time, since I make this free, some of you already heard this song before. So forgive me for that, that if you are hearing the same song. The major and the minor. So this is the basic or the base case. And this is a 70% factor. And the 70% factor also the V major exceeding 40 miles per hour, or the population is less than 10,000. Try to remember these things. Here they are saying the same thing. We have 3 curves, 2 and 2. And 2 and 1. And finally, 1 and 1. And again, the word fall above, it is believed I mentioned somewhere here. So fall above, and the hour is an hour, 4 consecutive 15 minutes. And the major street is still the total both approaches, and the minor is 1. But when you pick the hour, by the way, it must be the same hour. Don't pick and choose. I cannot really move around and say that, oh, this hour on this hour. I cannot really. If you pick this hour from 12 to 1 as your criteria, so you pick the major and the minor at the same time. I don't come here and pick another hour. You cannot pick. It must be the same hour. Be careful about that. Okay. So we have the let's plot 1 or 2 points just for the sake of discussion. So if you look, I can pick the largest number. For example, I need 4 hours. So if I have 990, because any 4 hours on an average day or a specific hour, okay, or 1 hour. So in this case, for example, I have 990 and the 310, for example. If I take the 1 hour, which is the warrant number 3, as I said, so 990, which is almost here, and 310, okay, so 990, and the 300, this is the 300, 310, it is somewhere here. Okay, so to the best of your engineering, take a scale with you. So 990, and I will be using 2 to 1, and this is 310. Something like that. Okay, maybe. So in this case, as I suggested, or I try to answer some of your questions because I know somebody will ask me this, that you already eliminated answer A and answer C because warrant number 1. Why we don't jump to warrant number 3? If warrant number 3 is met, that means for sure that because the 3 and 1 are out, so 3 and 2, so the answer is D, and I need you to do it. Okay, make sense? So this is something that I need you to be aware of, and I hope this is the clarification about this. The 85th percentile speed of 40 mile per hour. Something very important, speed studies, we cover it. And the 85th percentile is the one that adopted the current code. They adopted the 85th percentile. What is the 85th percentile? 85th percentile, but let me, before I proceed, because I see some of you already raised a question or ask a question or a comment or a suggestion or giving me something. Date is 4/12. Oh, did I write something different? Oh, 3/12. Oh my God. Yeah, like yesterday. I don't know why I'm still insisting that this month is. Ray, figure 4, okay. Confused on the 3 lines to 2 lines, okay. For example, if 2-lane major has 160 and major 35, V does not mean warrant. Let me look to Ray. Let me just correct one at a time. So this is 4. Yes, I agree with you, my friend. I'm still believing that this is March. I don't know why. Okay. Ray is asking a question about the these lines here. As you can see here, they have the 150 and 100, and they have the asterisk here to indicate what is meant by that. Note, the 150 vehicle applies as the lower threshold volume for a minor street approach with 2 or more lanes. Okay, so the 150 applies for this and this, because for 2, wait a second, for the minor street, okay, with 2 or more lanes, and 100 vehicle applies to the lower threshold volume on a minor approach with a 1 lane. So this one here, the 150, is applicable only for 2 or more lanes, because this one here is the minor. So the second here is a minor. Okay, and this is 1 lane and 1 lane. So the 150, you may say that probably this line, it shouldn't be a solid line, because right now the 100, I have 1 and 1, so this line here, so probably this line here, the solid line here, it should not continue, because when you come here along 2-1, 150, okay, as a lower threshold for a volume minor street approach with 2 or more lanes. So probably this solid line here, if we can make it not solid or get rid of it completely, okay, and I will look to the original document to see if this is a typo from our end, but this is the explanation, my friend. So the 100 is applicable to these two. where we have 1 on 1 along the minor, but the 150 is applicable here. So I hope this is the, and I will look to see if any other, I try to locate the MUTCD if I have it here. It could be a little tiny error here or there. Let us see. I will look at it. I don't like to spend time. I will look at it. And if there is a typo from our end or from the graph, I will get it to you, my friend. So I hope this is, and I print all the questions that you ask, and I will be glad to answer them if we did not get a chance to answer them here. Confusing having an extra, yeah. So I will look to the original document and I will verify, but based on the text, I believe the text is correct if I remember correctly. So probably this line here, why this line here for 2-1, this one here, no, both of them, this and this, they go here, which is making more sense. Okay, here it is. This for 2, 1, and 1, 1, which is the minor list, so the 150. But this 100, sorry, the 150 is only for 2 or more along the minor. But it's a good point that I will look at it and see if clarified or maybe. But based on the discussion, this line here, it seems to me, is a line that's causing the confusion. Okay. Thank you for all these questions. All these questions are valuable, and we are talking about the 85th percentile. When they are talking about speed, when they said that the V major exceeding 40 miles per hour mph, or the population less than the 10,000, or the population or population less than 10,000. So those are the criteria. But the V here is, we're talking about the 85th percentile. In speed studies, as I covered in the class, speed studies, we are using what is known as a cumulative. Cumulative. The word cumulative. Cumulative means additive. And we use the word cumulative in 3 situations, by the way. This is one of them, speed studies. Cumulative. We use also cumulative when we're talking about mass diagram. Mass diagram. And I believe in the NCEES, there is a problem. It used to be at the end related to mass diagram. Yeah, here it is. Still there. Mass diagram. And I'll be glad to go over even right now, since we're talking about cumulative, what they meant by cumulative. Okay, cumulative. So this is a first scenario or first situation we are using the word cumulative. This is the second scenario. And the third scenario we are using when we calculate what is known as the FM, which is the fineness modulus. Fineness modulus. I believe fineness is not correct. F-I-N-E-N. Fineness modulus. Or it was correct, fineness, F-I-N-E-S-S. No, it was correct originally. Fineness modulus, F-I-N-E-S-S, fineness modulus. The FM for sand. When we calculate the fineness modulus for sand, we use also the term cumulative or additive. So those are the 3 scenarios related to, or 3 situations that we are using the cumulative. Okay, in mass diagram, fineness modulus calculation. For the fineness modulus for sand, as you remember from school, the FM, it must be greater than or equal 2.3 and less than or equal 3.1. So the finest modulus for sand is between this range. Sand, which is the fine aggregate, as we explained yesterday. I solved some problem about mixed design yesterday for the construction PM, and we talked about sand and fine aggregate and coarse aggregate. But so this mini exam here, if you look to this problem here, which is a problem number 6, it gave you a speed survey on 2-lane conventional highway is shown. They went, and between 20 and 25, they found that there are 2 cars, and so on. Is asking about what is the 85th percentile. What is the 85th percentile for this mile per hour? Is most nearly, as you can see here, he put as a fraction. Normally, when this is a calculated 85th percentile, calculated. But when we report the speed, it is a 5 mile per hour increment. Okay, this is the rule that we use for reporting and posted speed. It's a 5 mile increment. You will never find the speed sign has 44.7 or something like that. Okay, but just for the calculations, for the calculated value, yes, we can have a fraction as indicated here. So since we are using the cumulative, so we need to create another or establish another column. And this column is, I can put it here. I know it is little tiny column, but it is. And I will call this column cumulative. And the way we establish that, we take the frequency and we put it 2, and 2 and 9 is 11, and the 11, and so we add this here, and after that we take this, add it to this, and so on. Take 11, add it to this, will give you this, which is 27. 27 and this is 5. Okay, and so this and this will give you this, and this will give you this. So 9 and 5 is 4, and this is 2, so this is 74. And I will take this and this will give you 85. And if you take this and add it to this, will give you 88. This is called the cumulative. You're taking the previous number and add it to the current, and so on. Did I all my numbers are correct? Let me know, please, if. After that, after we generate the cumulative, I am looking for 85 percentile, mean that 85th percent of the 88. This will give me a number. Here's my calculator here. So the 85th of the cumulative this will give you 74.8 vehicles. So in this case, since I know that the 85th is giving me 74.8, I will come here and see where is the 74. For 74, I have a range of 40 to 45 miles per hour. And for the second, which is 85, I have a range of 45 to 50 miles per hour from this table here for the cumulative. Okay, so I'm looking for this. So I am here 74.8. So I am somewhere here. So I am above 45. Again, uh, is it okay to use linear interpolation or use your engineering judgment for this and pick the speed that is going to be represented by the 85? So probably I'm close to 45 because so probably the answer D is my best answer. And if you go to my textbook, for those who and you review this section about the speed studies, we cover it, I believe, if I'm not mistaken, it was in chapter 1. Chapter 1, let me double check here to make sure that I still remember, or maybe it's coming. Sometimes I assume something and okay. So the and probably not. Probably no. Probably not. Probably not. It's coming. Okay. I was okay. No. Probably it's coming. This one I finished that. Oh yeah. No. It's not. It's not here. It's not here. Okay. Probably I mix my okay. Yeah. It's coming later on. Okay. So so this is something that I needed to be aware of. So this is, let's take a few minutes break and come back and we can continue our discussion. Just, I will survive as much as I can and let us see what's next. Thank you. Okay, welcome back, everybody. Let us move on, and I believe one of you tried to say something. So raise your hand. I have no any time. If you'd like to speak out or like to talk about something, you are very welcome to raise your hand. I will be glad to unmute you, and in this case, you can speak out if you'd like to add anything. For some reason, I didn't see your hand, my friend. Let me go again to the list. Who is? I don't know who is trying to, because I didn't see the hand here. I'm going over the list. No. Yeah. Okay. John, yes, go ahead, please.
Yeah, how are you?
I'm doing fine. Yes, what's up?
Very quickly, right? The previous question that
I can barely hear you. Can you speak a little bit louder, please?
all right. So, okay, can you hear me right now?
You are breaking for some reason. Go ahead and try to do your best.
I'm gonna do my best. The previous question, word number 3, right? And I just sent you a text. If you read the question, why did you pick word number 3? Because it didn't fall above the line; it was below the line. And why did you say word number 3?
Again, which problem is that?
The previous question. Again, that question, that one. Just a question right here, right? So you picked that. You said the answer is D, right? And
Yes.
And you said that it didn't fall above the line because we have a 2 major and we have 1 minor rod, right? And then by the time we picked the number 990 versus 310, that number was below that line. It was not above. It didn't fall above, but you still picked number 3. You said that number answer is D. And why did you say number? Answer is D.
Okay, so the 990 and the 310, it does fall below the line, not above the line?
Not above, because we have a 2 major and 1 minor rod, right? Correct? And if you choose that on the graphic shows below, but you said that it's above. Maybe I'm wrong.
Let me look at again, John. Maybe I did a mistake, or maybe. So this is the chart that I used.
Yes.
For warrant, okay, the peak hour. So
Yes.
so we are using the middle curve. Do you agree with me?
No, but
2 and 1.
okay. Now I see that. All right. Now I see that.
Okay.
Okay.
Agreement.
I thought that you picked that up. Okay. Now I see.
Okay, here it is. Yeah, just okay. Thank you. So the let me put you on mute again and continue our discussion. So here we go. Okay, all of you are muted right now, but you are very welcome to. As I told you, the cumulative approach is used in speed studies and in mass diagrams calculations, or mass diagram in general, and the finance modulus calculation. And I'll be glad to go over in any of these. The problem in the transportation, the blue book, the mass diagram problem, the one I was referring to, here it is in this book here. So the problem 537, let me explain it very quick, and I will be glad to send you. I do have some additional mass diagram problems. I call them 11 mass diagram problems. So this is a problem given the earthwork volume, volume shown in the table. The first balance point on the mass diagram is located at what station, and he gave you 4 answers here for the just very quick, and probably you heard this before, and for those who are not mass diagram is a graphical relationship between the volume and the distance or station along the center line or along whatever reference line is. So this is the station line, whatever the stations, which is a distance. It could be 100 feet or 100 meters, as you know. And this is a cumulative volume. The y-axis is a cumulative volume. And they agreed that the cut will be positive, and this is 0 here, and the fill is negative. And we can draw the mass diagram. We can draw it, or we can construct a table, and we can extract the information from the table, whatever information we need, and we can extract also the information from whatever diagram is given. The key word here is the word cumulative. So the word cumulative means additive, which is not the absolute volume, because right now, if we do have the original ground like this, as yesterday I was explaining a problem to construction PM, and probably some of you attended, and we do have something like this. Let's assume that I have a very strange profile. This is a profile grade, PG, a profile grade. Let me continue like this. Okay. And this is the original ground. The black one is the original ground, OG. And the profile grade is a vertical alignment, as you know, which is a profile grade or the vertical alignment. Vertical alignment. So the mass diagram is a graphical solution to the status of the earthwork along the facility to see if this is a balanced job or cut more than fill or fill more than cut. And as all of you know, we have the 3 scenarios. So this is a station extended a little bit to come here. Okay, station. So the so we might have cut equals fill, which is the best scenario, which is a balanced job, or cut greater than fill, where you have excess, or sometimes we call it waste, or maybe cut less than fill. So we have deficit. And in deficit, we can substitute the deficit by local borrow or imported borrow, where we get the soil from outside or locally from within the project limits or within the right-of-way limits. So this is a hypothetical situation here. Okay, we can translate this into this to get a mass diagram. So, and every time we are crossing these key points are very important, because here, as you can see, we have cut, and we have fill, and followed by cut, and we have fill. Okay, when the OG is below, we have fill. When the OG is above, we do have cut. So if we draw a hypothetical mass diagram to reflect this, these key points are very important because they will indicate the low and the high points, where we have a change from cut to fill. This is a high point, and where we change it from fill to cut is a low point. So if here I have cut, cut is a positive slope. Cut is positive quantity and there's a positive slope. So the volume will increase. It could be a straight line, by the way, or it could be a curve. So the volume over the cut here, it is going to be increased all the way, positive slope. And this is cut. Until I hit this point where I change it from cut to fill, so I will come down. Okay, so this is a high point. A high point. A high point on a mass diagram is an indication or a change from cut to fill. So I will move into the fill until all the cut will be fill. Okay. And I will continue all the way up to here. Try to draw nice. Okay. Up to here until the fill. And after that, I switch from fill to cut. So I will go up. It depends on the volume. So this is a low point on the mass diagram. A low point is changing from fill to cut. And the amount of the cut probably all the way up to here. It could be the cut is not sufficient, or maybe the cut is more than the fill area. So maybe I will go up a little bit, maybe. Somewhere here. Okay. And after that, I start to come to the fill. And the direction will change. And I may end on the fill side. This is a high, also another high point, which is a change from cut to fill, from positive slope. This is a positive slope to a negative slope. So this is just a hypothetical scenario, and I draw the quantitative mass diagram. It's called a qualitative, not a qualitative mass diagram, not a quantitative. I don't have the quantities. Okay, but we need to pay attention. This point here, the point I am crossing, this is called a balance point. Balance point, where cut and fill are equal. So the amount of the cut from here to here, it will come, and the contractor will come and dump it here into the fill area until he finished all the cut, and we are in balance. And after that, we still need full. So need fill. So we're going to get to fill. This is another balance point. So when we're crossing the station line, by the way, sometimes we call it balance line. So this is called the mass diagram. And there is a lot of problems. As I said that I have 11 mass diagram problems. I would be glad to send it to you in order to explain or try to make you more familiar with the calculations or doing the mass diagram. So if you look to the problem that's given in the NCEES, he gave you the XY, the coordinates. Maybe he's trying to attract your eyes to this. So this is the station line. This is in feet. And this is a cut, which is a positive, as you can see above the zero. This is our zero reference here. And this is the fill, which is negative. But I needed to be aware that these volumes are commutative volumes, commutative, not absolute. They should write commutative volume, but probably they didn't add the word commutative because probably they assume that we know that. And be careful, because he's asked what is the first balance point. Balance point means that when we have this is a station line, when we are crossing, if this is a mass diagram, for example, I start from here. When I across this line, this is called a balance point, where we have cut and fill are equal. This is a cut and this is fill, and this is a high point, for example, in our case here, and this is a positive slope, and this is a negative slope. So this is called a balance point. We can get the balance point from graphically plotting the mass diagram, which is time consuming, which I don't recommend. Even he invited you to do that, or do the calculations. But the diagram cannot be drawn until you finish the table. So the calculations are required anyhow. The calculations are required to construct the mass diagram. And basically, we are going to add another 2 columns. And the word cumulative is going to be, let me add them here to my left here, because I don't like to. And you can do this very quickly. It will take, yes, the first 2 or 3 problems, maybe it will take some time from you, but after you do a couple problems and understand the concept, it will be a piece of cake. Okay, so I'm going to create 2 or establish 2 columns here. One is called the algebraic sum, and this one is a cumulative. Normally, this is a cut, C, and this is the embankment, which is fill. Here, he did not give me any adjustment factor, by the way, which is like swell factor and shrinkage factor. Swell, either a swell percent or shrinkage percent. Sometimes they give you these numbers, like yesterday. Maybe this is 12% and this may be 14%, maybe. Sometimes they give you that, or sometimes they give you the swell factor. Swell factor is greater than 1, which is 1 plus the swell percent. Or he might give you the shrinkage percent. The shrinkage factor. Shrinkage percent is given, which is less than 1 for all soils except rocks. Rocks, it does have a shrinkage factor of greater than 1. But for sand and silt and the clay and gravel, name it, all these or mixture of these, the factor is less than 1. So here he didn't give me anything. That means that no adjustment. I need you to be aware of that. No adjustment is required or is needed. No adjustment is required. Here I will add, normally I prefer the cut, we said this is a plus and the fill is minus. I prefer to do that, at least when I say the algebraic sum here. So I will say that these are pluses and these are minuses. It will be much easier for me. Obviously, minus 0 is 0, but so here I have 0 and 0 is 0 at station 0. I have minus 1,000 and this will give you plus 2,000. And minus 500 and this, it is a 500. And the station 3 minus this is still 500. And this is 1,500. And this will give you 0. 1,000 plus and 1,000 minus. Here it start to have minus right now, minus 1,500. And this is minus 2,000. And this is minus 1,000. and this is minus 500. And finally, this and this is a 500. This is called algebraic sum, or just summation, algebraic sum. You are adding the cut and the fill, and I assign a minus to be much easier for me, instead of using letter C and F. The third column, sorry, this column here, this is the cumulative column, is the ordinate of the mass diagram, which is this. And in this case, it must be cumulative. Cumulative means 0, I will put 0. I will take 0 to 2000. By the way, let me stop here. You might see a 0 here, which at station 5, and the station 5 is among the answers, by the way. And you may say that this is the balance point. This is wrong, totally wrong. Don't say, oh, I have 0 here. No, the balance point, it must be obtained from the cumulative, not from the algebraic sum. Be careful about that, because they put some answers to match the mistakes or the. So I will this, and after that, I will take the 0 added to 2000 will give me 2000. I will take 2000 to 500 will give me 2500. 2500 I will add it to this will give me 3000. And the 3000 added to this will give me 4500. And 4500 and 0 will give me 4500. 4500 added to minus this will give you 3000. 3000 and negative 2000 will give you 1000. And 1000 and minus 1000 will give me 0. And 0 and 500 is minus 500. And 500 plus 500 will give me 0. This is the column of my interest, the cumulative column. This is the most important column. And as you can see here, I have a 0 once at the beginning, at station, which is at the beginning. This is not a balance point. This is like a trivial solution for differential equation. This is the beginning of the job. But as I move, I have a 0 here. At what station? At station 8. And in fact, this is the answer. This is, he's thinking about the first. Because I do have another balance point, which is this one here, which is 0 at the end, at station 10. In fact, the 11 mass diagram problems I have, 11 mass diagram problems, if I'm not mistaken, I have a problem similar to this. Even I ask you to plot it, I give you a grid to do it, to get a feeling how the mass diagram looks like. And there are many, many problems, okay, or many concepts related to the mass diagram. I can spend more time if you are interested, but there is no need to plot this. Now, in order to plot, you are going to use this, which is the ordinate and the station, and you plot it, and you'll get the mass diagram, and I will leave this to you. And you will find that this is the answer for the first balance point, and the second balance point is at station 10 plus 0, 0. Because in fact, this job is a balance. Cut is equal fill. This project here is balanced. How I know that? Because from the cumulative, I ended with 0. Because as I told you that the mass diagram, it could be either balanced or cut more than fill, or fill more than cut. So if I draw this is a station, and this is 0, and this is a plus, which is cut, and this is minus, which is fill. Sorry, my line is not perfectly vertical. Here it is. Sorry, my line is for my ordinate. So there are three scenarios. For any mass diagram could be either a straight line or a curve. It depends. Let's assume it is a straight line this time. You can come like this, something like that, and you end it somewhere here. Since you started from here and you ended here, that means that this cut equals fill, which is a balanced project. And this is what we are trying normally, what normally we try to do in order not to have excess soil or not to get soil from outside. No imported borrow and no excess. This is a perfect job. And this is a high point. As you can see, this is a high, and this is a plus, and this is minus. And this is the low point. Low point, it changes from fill, which is minus, to a cut, which is slope. Positive slope, as you remember from school, if this is x and this is y, so this is zero slope. All these lines have positive slope, and these lines have negative slope. Slope, which is dy by dx, as all of you know, slope, dy by dx, or tangent theta, where theta is measured with respect to the x-axis, or the horizontal. So this is one scenario. Okay, a mass diagram could have something like this. It could be also straight line or a curve. I could have something like that, and I will end it somewhere here. Let me draw nice here. Start from 0, and here I ended above the 0 or the balance line. So in this case, this cut is greater than fill. And how much is cut? Whatever the amount here, because this ordinate normally it is a scale. We put the numbers here as he gave it you in the NCEES. This is a balance point. This is a balance point. This is a balance point. And finally, we could have a mass diagram like this. You can have a mass diagram that is, let me try to find a color here to match. You may start somewhere here and you ended somewhere here. This one here, the fill is greater than cut. I try to make it very sharp, but not necessarily to be like that. So there are three scenarios, the one I mentioned. So from the calculations that we did in the NCEES book, we concluded that this is 0, that I started up and down, and I ended 0, like this one here. This is a balance or balanced job, and this is the best, as I said. So we need to know all these key points, and there is more than one topic are left. I didn't talk about them related to mass diagram. I don't expect, but I will be glad to discuss it later on. Like what is the station yard, a free hold distance, and I have about 5 or 6 equations. I discuss it with the construction group, and I can send it to you also. There are some equations for mass diagram calculations. I would be glad to send it. If I'm not mistaken, they are in my construction books, and I can send it to you. If it's not handy right now, I can try to remember where they are located, and I will be glad to send it to you, because the mass diagram problems are easy and straightforward if you understand the concept very well. So maybe here in the PM, I believe in the PM mass diagram. Yeah, here they are. Yeah, these equations here. 1, 2, 3, 4, 5, 6. Yeah, 6 equations. So I will be glad earthwork mass diagram relation, and I can go over each equation one by one. But so I will do my best. Let me keep this open. Hopefully, I can fulfill all my promises, because, as I said yesterday, when I say something, I really intend to do it, but because of the time, or because of I forget. Please, if I forget something, or if I promise something, so the equations, okay, for mass diagram. Okay, this is something that, okay, the equations for mass diagram. Okay, and we can talk about this more. Let us go back again to the exam. Hopefully, I can cover as many as I can. But let me grab a question from one of you, or we need to know the relationship between let us look to problem number 8. Number 8. The total volume of a 2-lane highway facility was measured and found to be 2460. VPH. The measured speed was found to be 46 miles per hour, while the posted speed is 40 miles per hour, and the geometric design of the facility was based on 50 miles per hour design speed, the curves, and all these things. And the directional split of the facility for the morning commute is 60-40. Directional split, okay, we call it D. Directional split D. I know we are using the D a lot. So the D here, we are saying that it is 40% in one direction and 60% in one direction. So this is what is meant by 60-40, 60% to 40%. And we use this equation when we calculate E cells. We are going to see this, the equivalent single axle load, E cells. Okay, we are using the D, the directional split, because I would like to know how much traffic, okay, going in this direction and how much traffic in this direction, because as you know, the ADT or AADT, this is the volume on both directions. So I have to split. So the split based on the percentage given in the problem statement. If it's not given to you, we will use 50-50. So 50-50 is the default. The direction split, 50-50 is the default. So if it's not stated in the problem, we go with the default as the number that I'm going to use. Okay. So here I have 2460, and he would like to calculate the headway in the heavier direction. The heavier the friction, I have 60% of that volume. So this will give me a certain volume. How many vehicle per hour? 2460 enter, 0.6 times is equal 1476 VPH. This is the first step I will do, which is get the heavier direction, because he told me. What is the headway? Headway is a definition. If I'm standing here with the stopwatch on the side of the road in a safe area, and I measure the time between two consecutive vehicles measured from the same point, either the front bumper or rear bumper to rear bumper, a fixed This time is called headway. So the headway is the, and this is seconds per vehicle. The units are very important. Second, these are 3.66, or this is our seconds per vehicle. So the headway, and we have an equation in given headway, is equal to how many seconds in 1 hour? It is 60 times 60, 3600. This is seconds per hour, divided by the flow rate. The flow rate, this is a vehicle per VPH, vehicle per hour, VPH, or vehicle per hour. Here it is, vehicle per hour. Units are very important because if you look to this, you will find that hour will cancel with hour, and we end with second per vehicle, which is a second per vehicle. So units are very important. So I got 60 times 60, and I do have 1476. This is given to me based on the 60%, 1476. So this will give you how many seconds per vehicle, which is S per vehicle, or SEC. So if you calculate that, so hopefully that this is going to give us a number to match. It's about 2.44. This is what I got. So the answer is this here. So the headway definition, I need you to be aware of that. What is a headway? And this is covered, I believe, in chapter 1 in my book. And again, chapter 1 of the PM, since I have one chapter at the beginning. So the headway here it is. It is flow rate, and here it is. Okay, this is the flow rate is equal 36 over the headway, or I can get the headway is equal to the 3600. This is equation from the HCM 2016. So try to locate the equations, or try to familiarize yourself with it. Whatever page number is, you should know where the page is. Okay, and which chapter is that? If you need to study to a degree that you know exactly where it is. You cannot go to the back end of the book and look for the index, and look in the index and see what page is that. No, you should know which chapter. Okay, or where is this equation, where is this table, where is this chart. Try to mark your book very well. But if you study very well and if you prepare yourself very well, I believe you will be able to locate subjects and sub-subjects easily. I'm not asking you to memorize everything in the book, but try to do your best, and I will do my best to keep helping you guys. Okay. So this is the first one. To find the LOS in calculating the free flow speed, which one should be used as the free flow speed? Is the design or the question is what the we have something called FFS, and the FFS is starting with the base free flow speed minus, for example, FL sub W minus F right lateral clearance minus 3.22 TRD raised to 0.84, if I remember the equation correctly. This is one equation. We used it before. And as I told you that this here, this is for a freeway segment, by the way. A freeway segment. Okay, this number here, the basic free flow speed, this it must be okay, measured, and we are using 75.4 as a default for freeway segments. And if you remember, we saw default unless given otherwise. Okay, the second equation that we used in calculating the free flow speed, for this is for freeway segments, by the way, freeway segments. We talked about the TRD, the total ramp density. If you look to the second equation, that the free flow speed, which is the base free flow speed minus FL sub W minus F total lateral careeness minus F sub A minus F sub M. And I hope that I remember this equation correctly. Again, remind me or correct me if I'm wrong, because sometimes I cannot remember. Let me double check, because, okay, probably not the same order. First of all, this M uppercase, that's fine. So this is for the equation is correct, okay? And this is the equation that we used for multi-lane highways. Multi-lane highways, which we call it the express. This is F sub A, which is axis, F sub M in the median, okay, the median type, as in this total lateral clearance, FL sub W lane width. And again, we have something is called BFFS. Okay, for the multi-lane highways, the FFS, it must be given to you. Or if you look to this table, they have some default values. Okay, let me see if I still remember that. Okay, and we use 60 mile per hour. It used to be 60 mile per hour. Okay. Okay. This is the table I'm referring to, Muhammad. It is on page 74 of my textbook. And this is the free flow speed, FFS. For the geometric, okay, for basic freeway segments, here there are some suggested default values. He said that the basic free flow speed limit plus 5 miles, this range here, and the potential data source is direct speed measurements, estimate for design speed or speed limit. This is for freeway segment. For multi-lane highways, for free flow speed, FFS, also they are telling us we can use this. This is called suggested default values. But normally they give it to us, or there is another section, since you mentioned that, by the way, in the highway capacity manual, is not in agreement with this, by the way. They don't add 5 miles per hour, they add 7 miles per hour. And my solution, I looked to the volume 4, and I found that they use everywhere the 7 mile per hour, not the 5 mile per hour as the list here. And they have a section, I can send it to you. This is why I stick with the 7 mile per hour. So it must be given, okay, to you, Muhammad. This is the range, for example, for, as I told you, that the speed limit plus but for the freeway segments, we are using the 75.4, and the justification for 75.4, according to them, I will say, let me write down, this is C table, at least you can look at it when you have a chance, table I-5, page 74 text. Okay, so look to this and let me know if you have any other questions, and I will be glad to to send you the it is a plus 5 mile per hour mph or a plus 7 mile per hour. So in the table they are saying 7 mile per 5 in the table, but in the text and the problem they are using 7 in the text, and so problems in their volume 4 they are using 7 mile per hour, and I use 7 mile per hour, by the way, in my second book. If you go to my second book, which is AMBM, I believe, yeah, book number, this AMBM book, you will find that I use a 7 mile per hour, and I told you why I use 7 mile per hour. Okay, so I hope this is the answer to your question, and if it's not completely okay, directed to your the answer you're looking for, or does it, please let me know and I will be glad to elaborate more. So the in mini exam number 2, problem number 15, is both the speed or let me look to problem mini exam number mini exam number 2, or not the exam, where is mini exam number 2? Let me look. I can remember. Let me try to look, Muhammad, and try to do your best. And as I said that, and always I said at the beginning, I said that if there is a typo or a mistake or an error, I try to yeah, I know that, yes, yeah. So the 4-lane divided highway in an urban, and so on. So what is, solve it. Here it is. He gave you both the design speed and the boss speed limit. So the design, this based on the geometrics, because we design for a higher speed normally. Okay, but the boss speed, this is a maximum speed that permitted, okay, on the facility. So the design speed normally is higher than the boss speed normally. Okay, unless in very critical situation. In a very critical situation, so the design value is normally higher, because I design, as you know, based on certain tangent length and curve radius, and so on. So side distance and all these things. So the design normally the design speed is higher than the boss speed, to be on the safe side. If somebody speed up a little bit, he is not supposed to speed beyond the boss speed. The boss speed is the one that it can stand in the court. Okay, and the police can give us, or the law enforcement officer, they give us tickets based on the boss speed, not based on the design speed. Whatever posted, this is the one. So look at it, and I will be glad to go over this problem, because I'm working on them also. Hopefully I can finish the solutions. Right now we are in mini exam number 3, and I'm doing all my best. Okay, so let us move on. We talked about also, since so this is a problem number 8. Problem number 9, very quick. Number 9, the same problem, I believe, with the same numbers. Yes. And he said the average spacing in the heavier direction, the spacing between two consecutive cars. Okay. So also, if you look to my book, you will find there is one equation. The spacing is given by this relationship, which is a headway. This is second per vehicle, VH or S, times speed, and the speed, it must be in feet per second. So in this case, if you look to this, second will cancel with second. This will give you how many feet, okay, per vehicle, and this is, so the headway, we just got it from the previous one, which is the 2.44. This is the second per vehicle times the speed. The speed is, we have three speeds, as I mentioned, or as he mentioned in the problem. It is the posted speed, the measured 46. The posted speed is this, and the geometric, okay, this is the design speed, which is, I said that normally it is higher. But the posted speed is 40 miles per hour, but at that moment we have the 46 mile per hour, so I will take 46 mile per hour, mph, mile per hour. And in order to convert it to feet per second, as you know, the famous equation, the famous factor, the 1.47. Do you remember the 1.47, which is from the stopping side distance, 1.47. So this will give you feet per second. So if you do this calculation, you are going to come up with something, okay. Um, so it is 2.44 and 46 times and 1.47 times. So this give you about 164.99 feet per vehicle, which is about 165 in this case. And I will select the answer A. Okay, the average speed, also this is another problem, problem number 10. It's related to the same thing. A lot of problems. We talked about corner side distance, but before the corner side distance, let me go over just to remind you with the peak hour factor. The peak hour factor is a factor less than 1. So the peak hour factor, it is always less than 1. Okay, it cannot be 1. Theoretically speaking, it has to be 1, but this is assuming that the volumes for every 15 consecutive minutes will be the same. But basically, the peak hour factor is the sum of the volume in the peak hour, divided by 4 times V15 max, the maximum volume occurring within this hour, and you multiply this by 4. So here he gave you 2 hours. Sometimes he give you 1 hour. If it's 1 hour, it's so easy and straightforward. Here give you 2 hours. You have to determine where is the peak hour. Okay, so if you take the first hour from 4 to 5, you will get the volume of these 4 quarters. Okay, and after that, if you increase it by another 15, you'll get another hour. So you need to determine where is the peak hour. And this is the first step I need you to know. First step is to, first step, not steep, so step is to determine the peak hour. Okay, and you will find that probably this number here this number here, this is 1,000 and this is 1,050. So probably if I have only half a minute or 1 minute, you'll find that this quarter and this quarter, they have the largest, and I have 900 here. So by inspection, you can say that this hour, which is from 4:30 to 5:30, is a peak hour. And you can do that. You can, but I need you to calculate it just between 4 to 5, 4:15 to 5:15, 5:30, and so on, and you will find this. After determining that this is a peak hour, so in this case, the peak hour factor is, I will add the 1,000 after I determine that this is a peak hour. So this is a peak hour. So 1,000 plus 750 plus 900 plus 1,050 divided by 4 times 1,050. And you will get a number. I don't know what this number. Let me do it very quick because I don't have the solutions here. 750 or 900, or sometimes I change the numbers, by the way. So I got 0.88. Sometimes when you see a problem, maybe so 0.88, this is my answer here, the peak hour factor. So if you are giving more than 1 hour, in this case, you have to work it out, and this is the first step, as I told you, to determine this. So try to do your best. I know there is a lot. For example, this problem here is a corner side distance. Problem number 12. Corner side distance. Okay, do you remember case A, B, C, D, E, F, G? And as you know, G is the most recent one. For a side triangle at uncontrolled intersection, which is case A, by the way, this is case A. Do you remember cases for case A, B, and we have B1 and B2 and B3 and C, we have C1 and C2, okay, and after that A, B, D, E, F, and finally G, the one they added this time in the green book, or the ash to green book. This is for roundabouts, and I send it to you if I remember correctly. Roundabouts, a small paragraph they added. There is no any calculations for this, but we have calculations for A, for case A, for B1 and B2 and B3. We talked about that. C1, C2, A, B, C, D, E, F. Do you remember from left? And all these things already we talked about it. So try to do your best. I most of the time, if I'm not mistaken, but I don't know what they're going to ask on the exam. So most of the time, I believe maybe they are focusing on the A, but we need to be ready for all the possibilities, So he said that the length of the leg along the minor road is 300 feet, which equal the stopping side distance. Assuming that the brake reaction time T is 2.5 seconds, which is standard, the design speed on the minor road is 25 miles per hour, and deceleration rate is 4 feet per second. This is a feet per second square, sorry. This deceleration rate is very small, which is A, by the way. If you remember, the stopping side distance, the SSD, okay, we have two stopping side distance on level roads, and with roads with grade, And I talked about level road. There is no such things called level road. Zero, no. It has a minimum G. Minimum G is 0.3 level roads, if you remember, which is 0.3% for non-snow areas and 0.5% for snow areas. But roads with grade, where the G is going to be part of the equation. For the stopping side distance with grades, okay, this is the equation which is 1.47, the one I just used it, VT plus the V square divided by 30 times A over 32.2, which is G, a plus or minus G. This is the equation that we used it a lot. The stopping side distance on roads with grade. Here he gave you the 300 feet along the minor road. But he gave you, this is, as you know, the deceleration, which is A, normally is 11.2 feet per second. Feet per second square, sorry. The T, the little t, normally the default is 2.5 seconds, as all of you know. And the A, which is a deceleration rate, 11.2 feet per second square. But here, probably he gave you something odd, a little bit or something not. So the grade of the approach lane on the minor road is, so the road is going up or going down, whatever he gave you, downgrade, upgrade, or so here this is a major road and this is a minor road. So I say that there is a car here driving, and it was found that the sight triangle distance along this one here is 300 feet. So what is the grade? I will put all the parameters. This is given 300 feet. V is given. T is given. The only unknown here is G. Solve it and please let me know if downgrade or upgrade. It's a very interesting problem. I need you to be just to, I think, if I'm not mistaken, I believe the answer was C. Yes, it is. Unless they change the numbers. Let me solve it. I don't like to. So this is something I needed to be aware of that. I will talk about the rest, especially signalized intersections. I added a little bit, by the way, at the end, some problems related to horizontal curves. I believe I found that probably to remind you or to help you with the horizontal curves. It tried to draw especially the problem that it has bearings or azimuths. For example, this problem here, let me draw it, and I will stop here because for example, here, not necessarily every problem will be given on the exam. It has a drawing or a graph or illustration. Okay, so two tangents intersect 2,000 feet beyond the station 10 plus 00. The back tangent bearing is northwest. So I have northwest. I will come here and draw some kind of my coordinate system. And they try to do this while you're studying. This is the north and this is west. So I will say that northwest, north 45 west, here it is. This is the back tangent. This angle here is 45 degrees. And the forward tangent is northeast. So I will come here at the point that it could be the PI, the point of intersection, and also establish my coordinate system. And this is north 15 east. So northeast is still the same. Don't change directions. Okay, this is what we agreed upon. This is the north. My grandfather and your grandfather agreed on that. Don't change it, please. South, east. and this is the same here, east, and this is south. So I will draw the forward tangent north 15 degrees to the east. Here it is. This angle here is 15 degrees. So this is the back tangent. And this is the forward tangent. So I said two tangents intersect 2,000 feet beyond the station 10. Station 10 somewhere at any point. I don't know where it is. Here it is. Anything you would like to say, here it is. This is station 10 plus 00. And the distance from here to here, it is 10. 2,000. So 2,000 means there's 20 stations, by the way. Okay. So the distance from here to here is 2,000 feet. And he said that there is a curve connecting these two tangents, between these two tangents. So I will connect nice curve between these two tangents. Here we go. Let me get a nice curve. Since I say nice, I'm using my protractor to do that. Here it is. Okay. And this is the radius, and this is the radius. It said that the radius is 3,000 feet. So this, I will call this PI. And the first question, what is the central angle? This here is the central angle delta, or I. Or if you extend the back tangent a little bit, this is the deflection angle. This from here to here is also delta. Do you see that? And we need to master this because, so this is the beginning of the curve. And this is the end of the curve, the EC. Or this is PC, and this is PT, point of tangency and point of curvature. So based on that, what is the angle delta, or the central angle? This central angle delta I have this 45 degrees. And this is also 45 degrees. They are opposite. And this is also 45 degrees. So 45 degrees plus 15 is equal 60. Agree or disagree? If you agree, that's good news. If you disagree, it's still good news, because at least we can and again, try to draw as much as you can during your studying sessions. Try to draw as many drawings as you can, because this will help you later on when you come to the and they are coming with some very, very tricky questions, by the way. They are really doing something very tricky problems. So if we are prepared ourselves, I believe we will be in very good shape. So the problems with bearings and bearings um, or azimuths / azimuths are important. Problems with coordinates, and we'll solve a problem if you remember practice exam number 1. Coordinates are very important also. So try to pay attention to these problems or these types of problems that were coordinates or azimuths or bearings uh, uh, are included in the problem. Try to do your best. Sorry, I have to stop here because I need to take a little bit of rest before I start my seismic at 1 o'clock. I'm so glad that I survived with you. I was thinking that I will not be able to make it because, as I told you last night, I didn't sleep very well anyhow. So let us do our best and we'll keep working together. Stay healthy and stay safe, and pray for you and pray for me. And I will do all my best to keep working with you guys until we achieve, or you achieve your ultimate goal, or we achieve the ultimate goal together. But thank you very much for coming today, and don't hesitate to email me, and I will do all my best to provide you with whatever I promised. If I forget anything, don't hesitate to remind me, because um, I may forget something, or I may something slip on my busy schedule. And thank you very much.